Assalamualaikum warahmatullahi wabarakatuh and good day everyone. I am Alwani binti Abdul Latif and today I will be representing my team members to share on our innovation project. As a start, our project title is Cockle Shell as partial sand replacement in concrete. Concrete is widely used as construction material all over the world because it is cheap, durable and easy to be molded. But when we look at the production of concrete, we use a lot of natural resources such as limestone in cement production and also river sand for aggregate. So the increased demand of these natural resources also increase quarrying and mining activities of raw materials, which somehow will lead to its depletion because this material cannot be renewed. Urbanization and land development without control will lead to negative impact to the environment. According to the study by Ministry of Natural Resources and Environment Malaysia in 2019, it will lead to shortage of sand, riverbed erosion and water quality degradation. If we look at the sustainable construction concept, we do our construction or building in a way that it meets today's need and to provide and conserve resources for future generations. So for our project, we would like to introduce the use of crushed cockle shell in concrete. So our objective is to investigate concrete's performance using crushed cockle shell as partial sand replacement toward these three properties. Number one is workability of concrete, number two is compressive strength of concrete, and lastly is density of concrete. For this type of concrete, we use cockle shell. In Malaysia, we have a few types of marine shell, namely cockle shell, mollusk, and also oyster shell. But among these three, we have decided to use cockle shell because of its rough texture. Okay, so for the methodology, first we prepare the cockle shell, clean and oven dry, and then we crush the sample into fine particles to make it as sand particles, and then we do sieve analysis so that result and discussion. For sieve analysis, the crushed shell was sieved using a sieve size of 0.6 to 2.36 mm. The gradation using sieve analysis method of the particles show that the sample can be considered as sand. For cockle shell concrete, we have four mixed design, which is CS 4% to CS 12%. CS 4% means that the replacement of cockle shell to sand is at the rate of 4%, while CS 0 is the controlled batches. Looking at the chart on our right hand side, it shows that with higher replacement of cockle shell, there is tendency that the concrete mixes become stiffer. For compressive strength properties, it shows that the value of compressive strength for CS 4% samples are higher compared to control sample. Overall development of compressive strength for cockle shell concrete reduces as the replacement of cockle shell increases. While for density, it shows that the presence of cockle shell in concrete is insignificant in the aspect of concrete density. Apart from that, we also estimate cost for concrete production. So looking at the data, for workable concrete mix ratio, which is CS4 and CS6%, production cost can be reduced by 0.5 to 0.7%. The consumption of crushed cockle shell as a sand replacement will open to a wide business opportunity in the construction industry. As a conclusion, data obtained suggests that cockle shell should be used at 4 to 6% of sand replacement. Slump test shows that the concrete are low in workability due to the rough shape of cockle shell. However, these properties can be improved by adjusting water-cement ratio and also by using admixtures such as superplasticizer. And for the density, the finding shows that it is insignificant in the aspect of that properties. With that, I end our presentation. Thank you very much for having us in this innovation competition. Till we meet again in the next event. Thank you.